Cement, which contains calcium oxide, that's right there, is mixed with water, that's right there, and to make concrete. And this here we are given the delta H, or the change in enthalpy, is negative, so that indicates this is an exothermic process. And this is out in the open to make concrete. Pressure is constant, then the change in enthalpy is going to equal the heat transfer. All right, so in answer A, it's going from the system. What direction is the heat flow? It's going from the system, which is the reaction, into the surroundings, wherever this is happening. Get some out in the air, maybe into the ground system, to the surroundings. This reaction is exothermic. All right, let's move on to part B. Compare the potential energy of the reactants and the products. So these molecules have chemical potential energy stored. All right, so we'll just do potential energy up this way. And the reactants, which is calcium oxide and water, these molecules have more chemical potential energy stored in their bonds. When these bonds are broken and rearranged, that requires energy. That's an endothermic process. And then to make bonds, calcium hydroxide, that's going to release energy. So creating bonds is exothermic. That's going to release energy, and it's going to release a little more energy than required to break the bond. So that's how we get this delta H, or the change in enthalpy, to be negative. What did it say it was? 65.2. 65.2 kilojoules per mole. A couple more things we can interpret from this is the bonds here and the reactants are weak, and the bonds here are stronger, which means it's a more stable molecule, which also explains this drop in potential energy. All right, I think that's it.